Getting started with GitHub Copilot and Visual Studio Code is easy, and now it's free to get started. Here in Visual Studio Code, press the Copilot icon at the top of the screen and click the Use Copilot for Free button. This will open your web browser where you can sign into GitHub and allow Visual Studio Code to connect to your account. VS Code will now automatically install GitHub Copilot, and that's it. Let's say hello to Copilot. Great. Now I'm ready to start coding with my AI pair programmer by my side. To learn more, visit gh.io/copilot.
I've always been interested in contributing to open source projects. What's a good way to get started? Love that question because there's so many good ways to get started. You could get started by just helping triage issues. So many open source projects have issues where the maintainers, they don't know if it's a real bug or not. A lot of repositories also have what are called good first issues. Home Assistant is this cool open source org. In Home Assistant, look at that. They have 2.9K issues. Do you see that? They have so many labels. That's amazing. Good first issue. Aha! They've already got some here where it's like, this is a good first issue for you to take on and fix. And also generally just thinking, what are some projects that I use, that I care about, that I might be able to help with?
Hi developers. VS Code users can now access a powerful new code completion model, GPT-4o Mini. This model has been trained on over 275,000 high-quality public repositories covering more than 30 programming languages. You can expect this model to provide more accurate suggestions and better performance. To enable it, if you have Command Center enabled, click down the arrow next to the Copilot icon, select Configure Code Completions, choose Change Code Completions Model, and you're set. Alternatively, if you're using the command palette, you can press Ctrl-Shift-P for Windows or Linux, or Command-Shift-P for Mac. Type Change Completions Model, select your preferred model from the drop-down, and that's it. Happy coding.
Honestly, like when I first heard the idea of a hackathon, I was like, that sounds like a terrible way to spend my week. Every developer I've ever met, whether they're writing their first line of code or they're 10 years into their career, has a million ideas on the back burner. And hackathons create this sort of siloed, like magical time and space where you're surrounded by tons of people building stuff. And you're also able to build stuff because you have no distractions. Food is provided, swag is there. I think that hackathons are incredibly powerful at any stage of your career. There's no substitute for setting aside time and place to build.
Hey.
So, yeah, you are muted the whole time.
Wow. Hang on. No. And so you know what? And I love this. This is so fun. I changed my mic setup a little bit. And yeah, so I shouldn't have done that. Hey, friends. Well, guess what? Now you get to sit here while I talk about how awesome it is that you're here today. So we're going to do that again. Welcome, everyone, to another exciting edition of Open Source Friday. This is what happens when you stream live and you're a production team of 1.5, if you count Wilson the dog, who likes to come on and bark from time to time. So my apologies for that. We're streaming live today. Today's stream is all about computer vision, and we have an amazing guest joining us here. Again, if you're new here, Open Source Friday is our weekly live stream where we're going to spotlight amazing open source projects and the brilliant minds behind them. One of them sitting right here to the right of my screen. If you're enjoying this content, please don't forget to like, subscribe to this channel, hit that notification bell, and all that jazz. I am thrilled to have Peter join us today. Peter leads open source initiatives at Roboflow, and he is a passionate open source contributor, building practical projects, creating technical content, and sharing knowledge through various channels, including his own YouTube channel, which I will share in a moment. Peter, welcome to Open Source Friday. Thank you for being here with your mic on.
I'm doing my best. Thanks for having me. And yeah, in many ways that helps me out because if anything on my side will not work today, I will the worst things that can happen will be equally
I
bad.
love it. Listen, one thing about our audience and our GitHub community, period, is that they are lovely. So they know things happen. We do things live for a reason because we want to keep it real. So this is real life.
Awesome.
Peter, we're here today. We're going to be talking about Supervision, which is a powerful open source computer vision toolkit. I followed you on socials before for a bit, and I've noticed I've noticed first I think it was like a soccer match. And it's the tracker for the individual players, which I found that super interesting. I'm like, what does that? So we're going to get a chance to look at that. And we're going to also get a chance to take a look at 2, and I believe actually 3 other projects from Roboflow, including Notebooks and Maestro. And one that you just shared with me before we started the stream that is like, yeah, it's fresh off the oven, okay? It's like fresh off the oven.
Week, like almost a week ago we released it. Yeah.
So amazing.
We'll try to use it today. And fun fact, yeah, I was actually going to show you the football AI demo that you mentioned, but yeah, information from behind the scenes, something broke. I tried really hard to fix it before the stream, so we'll have a different demo, but I hope still cool.
That's okay. And listen, we can always link that demo as well, because I think like folks, I feel like there's a couple of demos that you share with me that I can link with people. They can take a look at the Roboflow YouTube channel and go back and see it. And friends, things break, okay? That's what happens. So anyways, before we get started, and as we get started, Peter, I'd love to, if you could share a little bit about yourself. How did you get started in computer vision? And just tell us a bit about you and open source.
Okay, so it's a long story kind of, but I will try to make it as short as possible. Generally speaking, at some point in time, I made a wrong decision to study civil engineering. Finished it, hated, and decided that I need to come up with a new idea for life. Went back to the university, this time for software engineering, and had a very good teacher at the first semester that was teaching statistics. And I started to do Kaggle competitions, of course, be terrible at it, but learned something along the way. And, trying different things in the ML space, stuck with computer vision, started to do blog posts, started to do small open source projects on GitHub, and somehow, I don't even know how exactly, now it's my job. So computer vision is my job, but also open source is my job, which is pretty cool. So
that's amazing. Listen, you're living the dream, okay? This is, I think, a lot of folks in the open source space where contributors and maintainers would love to make open source their entire, their life.
Absolutely. I can imagine that. That was my dream for quite a long time. So, yeah. But I think, that's a testament to that is actually possible. So it's pretty cool.
There you go. All right. So first of all, tell us a little bit about Supervision. I shared, so the status that I've shared is, and this is what you folks seen in the chat. I think that's to that particular demo, right? With the soccer players.
Yeah.
But tell us a little bit about Supervision. What did it come from? Why was it built? What problem were you trying to solve? And then I'd love to understand and also get to know a little bit more about Roboflow as well.
Sure thing. Highly encourage everybody to take a look at the Supervision repo in the meantime. But generally speaking, the idea was that I was working in multiple companies doing computer vision. So that was in this later stage where I was already kind of computer vision is my job pretty much. And in every company where I worked did the same things. There is a certain specific set of utilities that any computer vision project, you need to have those utilities pretty much. Yeah. And every company rewrote the same stuff all over again. And I was like, okay, that's probably fourth time that I'm doing that. But okay, let me just come up with that from the top of my head. So those are usually not the things that are extremely hard to write. Those are unpleasant things to write. Things that you just don't want to write every time and redo every time. And when I joined Roboflow, initially there was like no specific idea on things that I should work with. I was actually joining like marketing team, being a dev role pretty much. And so bunch of what I was doing, because Roboflow is the computer vision company, is like create a lot of like demos for people so that they can get inspired by what is possible and start maybe to use the product and so on. So I started to create my own set of utilities. What I do is I usually try to build in public. So I just release the YouTube video and link the link to Supervision, and another YouTube video and another. And with time, we touched so many different topics with those videos that set of utilities kind of like grew. And something that was just a side project. At some point, we decided. I remember our CTO saying, I wonder if we are thinking too small about Supervision, something like this. And that was a moment that we found, oh, maybe that's not a just random repo. Maybe we can make it a full-fledged open source product. And since then, pretty much everything that we do is touching Supervision. It's powering product internally. It's powering pretty much any other repository that we build that is open source repository. Yeah. So that's the story. And when we talk about Roboflow, it's a computer vision company that allows you to build data sets for computer vision, train models, and deploy the models. And yeah, we also started to like build our own architectures of models quite recently. So yeah, we are trying to give every utility that you want to have if you want to build something with computer vision. Yeah, and we try to do it as easy to start, so that people that are usually like iOS developers and they only want to have this like one feature that is AI with computer vision, that they are still capable of doing that. Or somebody has a website and want to process documents, so they can still figure it out with our stuff. So we try to be as kind of like open to people who are not computer vision engineers but still want to use computer vision.
That is amazing, and that is most needed. So out of your own need to make things simple and not do the repetitive, boring, hard stuff again, this project is born. And a lot of even companies that back open source also depend on their product. I mean, it's in their interest that the project continues to grow and evolve. So that's an awesome starting point. Could you share with us some of like real world applications, like where you've seen Supervision making an impact? I know that, like, I love the demo with the soccer players, but what are some other applications for computer vision right now for folks that might not be as familiar with the computer vision ecosystem?
So two kind of different questions where Supervision is useful and where computer vision is useful. But I'd say that computer vision is one of, I am definitely on the hype train for AI and all the language models and vision language models and everything. I am totally excited, and I leave that topic. But I think that computer vision is one of those like rare things in AI that actually works well enough that it can power products and can solve real life problems on a daily basis, pretty much. So things where computer vision is used, as a bunch of our clients, for example, have factories, and in factories, you during the manufacturing, you can have certain types of faults. You would like to maybe automate the process to detect those faults so that they are not shipped with your product. Yeah. There is a whole bunch of use cases around like smart cities. So we would like to know if how many people go through certain places. We would like to understand our buses or train are overcrowded, measure that in some way so that we can react in those cases. There is whole a bunch of projects that are focused on wildlife, tracking movements of like wild animals so that we know where they are and how many they are. There are projects, recently California suffered wildfires. There is a whole set of automated projects that analyze the streams from cameras live to detect smoke and fire so that you can automate that detection automatically. in shops, you would like to do all sorts of different things. You would like to detect maybe if somebody is stealing, but maybe you would also like to understand how people are moving through the store so that you can identify those like points where a lot of people move. Stores tend to put some products over there that is kind of like, a way to pay me more money for that premium spot where a lot of people come, So there is like all sorts. Recently with VLMs, you can see a lot of like document understanding stuff so that you can process your invoices automatically. You can do,
Wow.
I don't know, automatically look for certain patches of text within the PDF files. So all sorts of applications. And like I said, computer vision, I think, is one of those domains where a lot of that stuff work, and it's making money for a lot of people. But also really cool.
And it's also very cool. And I love how you mentioned it, like, sure, you're full on board with the AI hype cycle, but this isn't hype though. Like, this technology is being used by millions of companies already successfully. So
yeah, absolutely.
it's
So
proven,
it's not
proven
like,
tech.
yeah, it's not like outcome of the recent wave of AI.
Exactly.
I was doing that before that, and a lot of people in that space were doing that before that. Of course, now we have new tools like VLMs, so a lot of those use cases, certainly around like reading text, where like, does that really work? Right now, it definitely works, and that's thanks to the recent kind of like changes. But all of that real-time object detection stuff worked. It's just way better right now. Yeah. So.
Yeah, that's awesome. That's awesome. Okay, so let's talk about supervision then specifically.
Mm-hmm.
Are you gonna be able to show us a demo?
I
What do you
hope so.
think?
I hope
Let's
so.
try it.
I wanted to show that football AI because I also think that's
It's
awesome,
a
and
cool one, yeah.
sports and computer vision in a single place, that's awesome. But I have a different one, and we'll see how well it works, and I'll show you two things in action. Can I share the screen already?
Yes, please go ahead and share, and I'll go ahead and bring it up. Awesome. Take your time. And hey, thank you everyone in the chat that was trying to tell me that you couldn't hear me. If you saw what my screen looks like, you would understand why I couldn't see it. I have like 10 different superimposed things. I can barely see my own face. And welcome. While you're getting set up, welcome Paul from Italy. Welcome Linda from New Zealand. Welcome New One from Canada. We have such a international audience today. Hello Mukul from India. And hello to my boss, who can't wait to see this demo. Hello, my boss from Chicago. Awesome. All right.
I'll be visiting Chicago soon. I should.
Get out. There you go. There's a really amazing tech scene that's happening in Chicago for sure. All right. So I've started sharing your screen. So tell us, what are we looking at?
Okay. So I'm sharing the Google Colab right now.
Okay.
So it's not ours, but we use it as one of the kind of like vehicles to show computer vision, because one of the things that is true around AI is like you need GPU pretty much to do it efficiently. GPUs actually originally were invented to process videos and images, so they are uniquely suitable to do that. So this is the Colab, but we will use two projects today. The first project is Supervision, and that's the one that I'm showing you right now. And the second one that we'll use is that one that is coming fresh off the oven that we spoke about, which is RF Dieter. And that's a model that we released a week ago. And what is very cool about that model is totally open source. It's open source from the code perspective, but also from the checkpoints perspective, which is not that obvious in the world of computer vision and object detectors. So yeah, I'm very excited, and it's also powered kind of through Supervision. That's using Supervision to process the outputs. So there's that as well. So those two, and we will try to. We'll succeed for sure. I will show you how to build something like this. So essentially a a system that will detect, track cars and calculate their speed.
Wow.
And extract their position in the real life and map that onto a model of a representation of that speed of that road. Yeah, so something like this, and with all that with tools that are under either MIT or Apache, so you can build products around it if you would like to. And of course, this is just just an idea, just one of the examples of things that you can build, because just want to make that clear. Cool. So I installed all of the dependencies in that collab before we started the stream, so that we wouldn't spend like 5 minutes watching at the terminal output in the meantime. But maybe one more information. All those demos, this and others like Football AI, for example, all of them are available in other repository that we have that is called Notebooks. We store probably 60 or 70 different notebooks over here, 70 because 50 plus 21, 70, that cover all sorts of computer vision topics, from detection, segmentation, up to tracking and building this kind of more elaborate demos. So this is pretty much one of the notebooks that is coming from that repository. So another cool resource that you can take a look at. Cool. So it's all in Python because Python is the language for computer vision and AI. Yeah, if you don't know Python, I hope it's descriptive enough that we'll be able to figure it out. Okay, so one of the things that Supervision does is provide people with those utilities that I mentioned. Some of those utilities are around video processing, where you need to loop through the frames of the video, or you need to save those frames into the video as the output, or you would like to extract a certain part of the video. So we have a whole API around the videos. And one of those parts of that API is looping through the frames. So I, before the stream, downloaded one of our example videos where we look at the road and there are cars passing. Important thing is, of course, that you need to have a certain positioning of that camera so that the view is not obscured. Computer vision is great, but there are some things that are really hard to do if you position camera well. Like if the camera would be really low, it would be way harder for us to detect all the cars, for example. It's way better if we have some height advantage. And now what we would like to do is we would like to detect cars on that scene and draw some sort of representation of those cars. And to do that, like I said, we'll use one of our two of our packages. So the first one is our RTD-TR open source model that I will just load into the memory with that line. Then I will extract the frame from the camera, and then we will maybe use a simple visualization for now, so that people would understand. So one of the things that Supervision have, one of those things that are definitely part of every computer vision project, pretty much, and a lot of companies pretty much rewrite the same utilities all over again. Those are annotators. So we will use a simple box annotator to just initially have a nice representation of those detections, and we'll maybe build from there. So I'm just extracting probably the simplest part of that demo. So what we are doing is we are loading the model into memory. We are taking the first frame of the video, and we are annotating them with the simplest bounding boxes. And now this is a pre-trained model. So models are usually pre-trained and fine-tuned. Pre-trained in world of computer vision detection usually means that there is this data set created by Microsoft years ago called MS-COCO. and it has like 80 classes of those, like the most common objects that you can imagine. So car, person, truck, giraffe for some reason, and elephants, and some fruits and vegetables. So all sorts of like random objects, probably distinctive enough that it was easier for models back then to do that. And that is standard. So we release models pre-trained on Cocoa, then fine-tune them on custom datasets. So this one is pre-trained, but in that repository that I linked, there is a code to fine-tune on your own datasets. You can have the dataset on Roboflow. You can have your own dataset. Doesn't really matter. It's fully open, so you can fine-tune that. And but we are using the pre-trained, like I said. So we have cars, we have trucks, we have stuff like this out of the box. And like I said, one of the things that Supervision does really well is help you out with annotation. So what happens very often, you have clients, and those clients would like to see some nice demos. They would like to see a lot of like, flashy representation of whatever is part of their solution. So we've come up with the help of the community with, I don't know, like 30 different annotators, and you can combo them. So all of they are like composable. So you can say, oh, I would like to have this, and combine that into a cool representation. So for example, here we have those like triangles, ellipses. So you can do all sorts. This is my favorite one, kind of like called Halo, which looks like you have kind of a certain glow around those objects that you detected. We have all some inspirations from video games, and all sorts of like possibilities. Blurring, which is another very popular representation. When you track, you can draw those like tails behind certain objects. So maybe we can play a little bit with that during the stream. But generally speaking, because you can compose them, you can, for example, take bounding boxes, and what we will do in the cell below, that's why I kind of like pick a few things, we will combine those bounding boxes with labels. So now we can say, okay, this is the car, this is the track. That value next to it is what we call confidence, which is how model usually tells us, how certain it is that that object is actually existing over there, and about the label of that object. So in our case, and you can typically, what you do is you manipulate the threshold so that the model don't detect something that we call false positive, which is object does not exist there, but object model for some reason detect that. So sometimes stuff like that happen depending on your training and how big is your fine-tuning data set. Those sorts of things can influence that. So there's that. Now, what can happen, and what you would see probably, is that objects that are further away in the distance will very often blink, because what happens is that when you process those images, you downscale them usually before they go through the model that detects them. So when you downscale an image, something that is already small on the image becomes like a single pixel, or like 5 pixels or something like this. So what we want to do in projects like this one is we would like to get rid of those objects that are further away in the distance. So Supervision gives you another tool to do that. It's called Polygon Zone. And what we can do is so before the stream, I kind of like measured where the zone should be, and it's all expressed in coordinates, and world of computer vision are expressed in pixels, starting very intuitively in the top left corner and going down and to the right, x-axis to the right, y-axis to the down. So those are achieved, like, I got those coordinates by just doing what I just described. And when we run this, we can display that zone. Yeah. So Supervision has all sorts of utilities to process those zones. We can filter by zone, so we can get objects only in the zone, out the zone. We can have all sorts of rules saying that if objects just slightly touches the zone, it's already in the zone, or it needs to be entirely in the zone. All sorts of different, tweaks and options for computer vision developers so that they can solve their problem, because clients very often have a very specific requirements. So you need to be able to fulfill them, and Supervision helps with that. So now we will skip that portion for a second, come back to that later. What we can do is we can use the polygon zone and filter. So what all we need to do is I take pretty much the same code that I had above, but I just create one more variable called polygon zone, and I add this line. And this line says if given detection triggers the zone, which means it is in the zone, then I would like to keep it. So that's how it works. And if it's out the zone, then I would like to remove it. All that utility, I hope it will work, returns a NumPy array. So in that whole library is built on top of like OpenCV and NumPy. So they're very popular libraries that are a staple of any Python data project, but they tend to be very low level. So you would need to write a ton of code. Like I created a tutorial for this specific use case before we had like Supervision fully built, and it was like 1,000 lines of code that you need to write, versus you will see probably 30 or 40 right now in the final version. So what we can do right now is I can run that, and you see that we only have objects that are here. This is very important because we will limit that blinking, and it will the final result will look a lot better. Because I know how those things work, I can, meaning that it's usually kind of slow to process that, download the video from the collab and show it to you. I kind of like pre-done that before the stream, so I have kind of like all the steps that we will do. I already have kind of like the visualization that will be the outcome when we process that on the whole video. Okay. So that would be the final outcome. A part of the fact that those distant detections are still present there, but would be probably removed if we would run it with filtering. So this is kind of like the pure detection. Now, to be able to count objects crossing the lines, or to be able to measure the speed of objects that move, you need to have tracking. And Supervision provides you with utilities to run tracking. So over here, for example, you can import from Supervision ByTrack. This is one of the top trackers right now that you can use. So trackers pretty much do something that's very simple. So all of those detectors, they process every image separately. So for them, if you pass every frame of the video, they still think it's separate image. So there is like no knowledge stored about, okay, this is the same object that I saw in the previous frame. All of them look like, I never saw something like this before. I don't know anything about it. So now what you do usually in computer vision, you have this detector that gives you those bounding boxes, and then you, on top of that, use tracker. And tracker cares about the continuity of the scene. So it gets the bounding boxes and say, okay, that's the same object that I saw in the previous frame. So let me assign the same tracker ID to those objects on the first frame and the second frame and the third frame, so that we can know that it's the same object and we can know how it moves, for example. Very important in that demo, sport demo that you mentioned, but also very important in use cases like this. So we'll run that code in just a second, but there are a few intermediate steps that will happen over here. So I just want to show you all of them along the way, because it would take us a lot of time to kind of like process each of them individually and show you the output. So this is the output with the tracking. So we see that right now we are no longer seeing like a car or track. We see a consistent tracker ID that is being passed between the frames. Those are the effects that I mentioned to you. Like if the car is far away, then we see it blinking. We see those like random numbers here, but all of those detections in the front are consistent. That's why we are doing that filtering. so that we can get rid of those like less consistent predictions. And now I show you the output that is already with that filtering. Yeah, so you can see that right now we'll only have consistent IDs, no more blinking over there. So anytime that the new object gets in the frame, it will get the tracker ID, and we can work from that point. Okay, so this is all great, but we would like to go beyond that. So right now we know where the objects are, and that's what is the object, and we know the tracker ID. But what we would like to know is where that object is in real life. Yeah, and this a little bit requires a little bit of prior knowledge, let's call it this way. So what you usually do for use cases like this is you go to your client and you say, okay, where is that spot? They either measure that distance, or we just use Google Maps or whatever. In my case, I was using Google Maps and identified that, what is the distance from here to where the camera is, so that we can later on process that and use that in our math computations. So what will happen right now is I will go a little bit higher, and we do something called perspective transformation. So this is a simple utility that will take the coordinates of our expressed in those coordinates on the frame. So like I said, pixels from the top left corner to the right and down, and convert them into real life dimensions. So it turns out that this road is, I will use meters because that's the measure that we are using here, but it's 25 meters from here to here, and it's around 250 meters from there to here. So
that's within the bounds that you set, right? Within the bounds that you set for the video. Okay.
Yeah, exactly. So now we know where this bounding box, this polygon is on the image. That's our source, and we know where that bounding box is in the target, which is the real life dimensions, real life distance between those points. Now we are using OpenCV pretty much to perform this kind of like clever math that is the same math, for example, that you do when you scan documents with your phone. So you hold the phone and it identifies where the corners of the paper that you would like to scan, and then it's able to kind of like warp the image that you took into a nicely formatted scan that you would do with like photocopier back in the days, but right now you can do that operation. So it's doing exactly this. The only difference is that right now, instead of moving the pixels of document that you scan into this nicely formatted way, we are moving the pixels of the frame into a space that would be 250 meters by 25 meters. Yeah. Okay. So there is that. And when we run that, and we will be running that in a second, we would get something like this. Yeah. So this is for exactly the same frame. Now we just took that representation and we just placed it over here. I actually explained the whole math, and I will probably not do that today, but I actually explained the whole math in my YouTube video that you will find in our YouTube channel. It's I guess speed estimation or something like this on Roboflow channel. So I think
I'll share it again. Yeah.
So, but back then we used a different model because we didn't have our own model. Now we do that all with our model and our utilities. Yeah. So there's that. And when we will run, so now I will trigger the processing for the whole video and kind of explain additional stuff that is happening over here. So it's pretty much what we discussed. We are doing detection, we are doing tracking, and we are doing this perspective transformation to go from the video frame into a real life dimensions. But we are doing that for every frame of the video. So if you have a video, it's usually 25 FPS or 30 FPS. That means, for non-gamers over here, frames per second.
Frames per
That
second.
means that every second you actually push 25 or 30 images. Those are individual images. They are just moving so fast that we perceive them as something that is smoothly moving. So what I'm doing right now is I'm looping through those images. I'm picking frames from the video. I'm running exactly the same code that we ran for a single frame. And I'm storing all of that into pandas data frame, which is another popular Python library in data science. So I'm memorizing the frame ID, so kind of like the index of the frame tracker. So this is the number that we get for every image. And I'm memorizing X and Y position, but after that conversion. And when that is happening, this is kind of like the output. So this is the representation. You can see that right now, all of that is in meters. Yeah. So we see that the car is moving from there to there. It is consistently the same distance between the edge of the road and the car is around 5 to 4 meters. And they are moving towards us. So the counter of distance is growing. Yeah. So this is the stuff that we kind of like memorize in that pandas data frame, so that then we can recreate that in 3D space. And that's how it works. But obviously, if we know how many FPS the video have, we know that if 25 frames passed, that was a single second. Yeah, if 100 frames passed, that was 4 seconds. So we know the distance, we know the location, and we know how much the objects move in that time, and we know the time, which means that we can calculate the speed, or at least approximate the speed. Yeah, and this is also happening over here in that code base. You can see that we have a utility called speed estimator, and it's doing exactly this. So it's just memorizing our coordinates that we calculated, store them in the array, and every frame we actually calculate the distance traveled versus the time that passed, and we divide that, and we get the distance, the speed, sorry. And once we do that, we get, do I have like nice looking output of that? Yeah, I have it. Okay, cool. So we get something like this. So we get so exactly what happened is exactly what I said. We just know where they are. We know where they were a second ago, so we subtract the location to get the distance. We know that second passed, we divide that, and we have the speed. Yeah, so in Europe, I can tell you that it's pretty accurate that the speed that trucks usually travel is 80 kilometers per hour. And yeah, you can drive around 140 on Polish roads, for example. So all of those seem that they are correct. Of course, for something like this to work, like I said, you need to have specific place where you have straight road. You need to have specific position of the camera. You need to know those like real life dimensions. But there are also like other things, like road should be optimally flat, because that math transformation from one perspective to another will give you wrong. That's why you need to put your paper when you scan it on the flat surface, because when you scan it, it needs to be on the flat so that it will be correctly mapped from one space to another. But overall, that thing should work if on like highways or things like this. So we also mentioned that in our YouTube video that those are the considerations that you need to take into account when you're doing that. But you can imagine if it works here, you can apply it on, for example, on the conveyor belt in the factory. So you have stuff moving from there to there. We can know what that is. We know where it is. We know that's the same object that it was here. It's here. You can use all of that. For example, a lot of factories, for example, count how many objects they produce, because plot twist, a lot of factories don't really know how many items they produce every day. So they would like to track that, or they don't know how many fault items they produce. So they would like to track that. So this is like straight up, you can take it from here and put it in the factory and calculate similar things. Yeah,
that's fascinating because you take this raw video and it's it just turns it into like all this actionable data. For the example that you're showing us, like I can think of a million reasons why like a city will want that, no? Like for like,
Yeah.
I don't know, speed
Yeah.
trapping, and maybe for bike routes, or analyzing like the quality of, like, not the quality, for the maintenance of the roads itself.
Yeah. You can also
Very
put
cool.
a single line over here, and now you can count how many cars move from that direction into here and in the other way around. So cities, for example, have sometimes the lanes that are changing the direction during the day depending on the traffic.
Oh,
And they can
clever.
just say, okay, right now the traffic is going this way, so we can just swap the lane, and they just swap some lights, and now that lane helps to move from that direction to other because the traffic is going there. Yeah.
Yes,
And
traffic flow. Like,
yeah, exactly,
excellent.
exactly. I had another example that I maybe will show you if you will give me enough time, but we have maybe it's in the GitHub repository of Supervision, so I don't need to look for it very hard. Okay, so here's another one, interesting. You can track the traffic in different directions. So you can have I don't know why is that working so terribly right now. GitHub is okay.
It's
So you
because we're
can
live.
say,
But
yeah,
okay.
exactly. So you can say, okay, I'm interested in how many cars are going from this part of the city into this part of the city, and you can identify the key cross section, and then you see that those like very small numbers over here increase every time that when the cars from yellow part of the road came here. So we have 6 cars from here. We have 2 cars going into here. And yeah, we've built kind of like the whole demo around that concept where we were able to say, oh, see, another thing that you see that from the blue one to the red one, there were 2 of them. And here there were like 1 from the red side and 5 from the blue side. So you can do a lot of like this real-time analytics to get that information. Yeah,
That's amazing. I want to take a quick look at the chat just to make sure I'm not missing folks' questions.
Mhm.
I know early on when we were talking about the models that you're using, there was a question, and I'm scrolling up, and I'm sorry if I'm paraphrasing it because I don't remember, and I apologize for that. But it was around, are there VLMs for different applications? Like I think the question was about maybe medical radiology. Are there VLMs for that already, or how does computer vision fit in there?
So how it works is you usually have a VLM that is, like I said, pre-trained on large data sets. So very often those like big labs like Microsoft or DeepMind, they release, or DeepSeek recently, or Qwen, they release their models, but they very often have a secret data sets that they use for training. So they open source the model, but the data set is not there. So they pre-train on those like gigantic data sets. And those pre-trained models, they tend to have some knowledge about like medical stuff, but not that big. One thing that I can show you in the DETR, when we released RFDETR, we checked how well it fine-tunes on different data sets. And medical is the one that usually scores the lowest, because in those pre-trained data sets, there are usually not that many medical images. So those pre-trained models tend to be not very good at medical, and because the pre-trained stage is usually the most powerful stage, where you have dozens of hundreds of GPUs and gigantic data sets, most of the knowledge comes from that stage. Then when you fine-tune, it's a lot harder to fine-tune on medical images, because the model that went through all of that training, it has like little understanding of the medical images. So you need to have a good data set to fine-tune it. But it's usually a lot harder to solve like medical problems with computer vision right now, because you can imagine why. All of those images of X-rays and all sorts of other like visual, they are private. Yeah, they are private. People don't want to share them, so you don't have data sets. So usually when you benchmark, like we benchmark, so this benchmark checks how well RFDETR fine-tunes to those new applications, those what we call downstream tasks. And It's still the
Peter.
best across all of the models that we tested, but you can see compared to other tasks like, I don't know, industrial, where it's very easy to have data sets for the pre-training, it is scoring like 12 points in MAP, which is a gigantic gap in the work of computer vision. I will not dive into that metric, but it's a big difference. Yeah.
So what did it test the best on that benchmark testing? And this is to help folks that are not able to see it, and me because I can't see the graphs very well. What was the best result? No, it's not your screen share. It's just the way my screen is set up. What was the best, like the most, the highest score in which benchmark for what application?
It's usually, like I said, it's usually the easiest to take computer vision tasks and apply them in industrial.
Okay.
Yeah, industrial cases, because there is like a lot of images. Fauna and flora, that's another one where you have a lot of like images flow in the internet, so it's very easy to create data sets. So those models usually are pre-trained. Sports, yeah. So those are the easy. Aerial is usually hard, but surprisingly, it turns out to be pretty good at this benchmark. Yeah, but medical, if we talk about specifically about it, is the key thing is the data set. But if somebody who asked that question, if they work in the company where they have access to medical data and they would be able to train it, so anonymize that and train on that, you can use our library called Maestro to fine-tune VLMs. So if you have the data set, you can take one of those models made by Qwen or DeepSeek or DeepMind and slap your data set on it and fine-tune it.
Aha! So that's what Maestro is then.
Yeah,
this is
Maestro
how we can
is
find
a framework that is. We wanted to help people who used to work in the computer vision space, those like me who don't. I work with VLM, so I'm not a good example. But a lot of people worked in the space, and they are still existing in this era of like detection, segmentation. Now we have VLMs; they can do so much more. So we try to help them to use the same data sets that they had for the previous tasks, but be able to fine-tune the new models because they work completely differently, and it's not that easy to go from one paradigm, let's call it, into the new one.
Okay, that brings me to a question that I think is my question. Sorry, friends, that's the advantage of being the person at the show. I get to ask my question. For a person that has, let's say, a mid-level proficiency in Python, like how difficult is it then for them to go in and use supervision? Like how I feel like this has already extracted a lot of the complexity of working with these models, but I got basic Python skills. Like, can I get it up and running? What do you think?
I think so. The idea here is, of course, that we would like everything to be as easy for beginners as possible. We have tons of tutorials. I think that the notebooks is probably the top place where you can go. I frequently hear is one of the most underrated data, resources to learn about computer vision, because we started to do it like 4 years ago, and right now, and for 4 years we try to stay on top of what's the hottest in computer vision and create tutorials. So we are right now in this stage that when the new model drops, people are tweeting at us that when the new tutorial is coming out. So we create literally dozens tutorials on top models through the years. So all of those we try to have, as you can see, we try to have a situation where you have a blog post and you have the YouTube video that goes with that, and we have the code. So if you are like fairly good with Python, like you can understand what is happening on the screen, then I think you should be able to certainly play with those notebooks and learn a little bit. I can show you like a quick compilation of what supervision can do. So you already saw that video where we do that, but this is the video that you are talking about for football. We have like all sorts of like pose estimation. We have the speed that I showed today. You can measure how much time objects spend in zone. You can detect certain things. You can do facial expressions.
So cool.
All sorts of like analytics in the city that I was talking about. So Yeah, all of those projects that I just showed you are in the repo, so you can just open up in the notebook. It all runs in Google Colab, so you just need to have like a Gmail or something, and you can get a GPU for 8 hours, like not a very beefy one, but good enough to
play around. Yeah, that was a question actually earlier. Can it track hands and fingers? I think
yeah, absolutely. I mean, I don't have a ready example to show you that, but at Roboflow, we have something called Roboflow Universe, which is, I think, that the largest kind of like open source repository of already pre-annotated data sets.
Mm-hmm.
And you can see all sorts of stuff, wildlife, some bones, whatever. But if you search for sign language, for example, a lot of people have built like applications built based on that. So they have annotated those images with sign language so that you can build like iOS apps that you can just look at somebody, using the sign language, and you can read what they are saying. Wow. But we can also go deeper. So we can also, like over here, I'm tracking the pose of the players. But you can imagine that if I can fine-tune the model to detect individual joints on the person, I can also fine-tune the model to identify individual joints on the hand. So we have some developers in the community who have done that, and they built like a gesture detector that can, I don't know. I saw, for example, demos where people were drawing with fingers, or they, made the pen larger or smaller depending on like gesture like this. So all of that, is definitely doable with computer vision, and like individual fingers is not a problem in 2025.
That's amazing. We had a project here, Open Source Friday. I gotta find it and place it on the chat. But it was it was called Zamba, and they use machine learning, computer vision to detect and classify animals in camera trap videos. Mm-hmm. So it was for wildlife conservation. It's just one of those, like, I didn't connect it until now, like we're talking about it. I'm like, that's just the wildlife examples that they have, like one of the many ways that you can use computer vision for something like wildlife conservancy. I mean, it's incredible. That's just amazing. Let me take a look and see if there are any questions.
Had a customer that literally had a data set of like whales, and they had, it's not that they knew that this is the whale. Like they have like individual whales that they know the names of those whales, because those organizations track actual movement of like individual animals. Mm-hmm. So based on like images taken from the boat where the whale was like coming up to take a breath, they could identify what whale was that based on, like, they have like scars. Being a whale is not easy. You often get injured, so you have certain properties that then you can train the model to do that. So for example, you can even go a step further and not only know that it's a certain species, you can know exactly what individual animal is that.
Yeah, that is amazing. Let me take a quick look. And I'm sorry, Peter, I hope you got time, because we're going way over the hour. But it's so interesting.
I did a lot for GitHub to notice that what we are doing. So now I have time. I can.
Beautiful. There's a question on the chat about real life applications. And I think, what is it? This is where the next great startup idea is going to come from, right? What can the startup use to solve Roboflow? Listen, if you're in medical field, there's a huge gap there right now. I can think of definitely just taking a look at the way the models and the information that's out there. Medical startup that comes and fine-tunes a really good data set for radiology analysis or something like that, you're gonna make bank. But what any other cases can you think of that are not, just maybe something that is missing out there, or anything that you've seen that's particularly interesting could be another.
I mean, one of the things that we want, I can tell you what we want to build, because we see a niche in that. So one of the projects that we want to release this year is around tracking. So I showed you tracking, but tracking is not like, it's not a solved problem. Like, there are so many things that can go wrong, for example, and it's maybe not the most hot topic right now because VLMs probably are, so vision language models, those models that can do, like, we all saw the demo by OpenAI recently where you can upload your image and it's right now a comic book or whatever, so those are also VLMs. But for the real-time and real-life applications, I think tracking is one of the places where we still don't see a solution that solves the problem. So what can happen, for example, and that can happen specifically in that example, I'm not sure if we'll have a moment where that happens, but very often those tracker IDs that we talked about can get swapped. So imagine a situation where two players are passing by and they are, for example, both from the same team. So from that distance, they look kind of similar. Yeah, they all have, I don't know, yellow or red jerseys, whatever. And the model from that distance, see, okay, those two objects that I saw, okay, and now they passed, and the tracker ID get messed up. So, for example, that is the kind of like example of the use case that I think is not necessarily still solved to this point. But other than that, it's probably VLMs right now. VLMs are huge models. Like you need like, I don't know, 64 GPUs to run some of them.
A lot of compute.
So a big part of research right now is also how to make them kind of smaller, especially in the open source space, because obviously those like big providers that have those APIs, they don't release the models, but they run them on their own servers. They manage that. But in the open source space, there's a lot of work into like making models smaller and more efficient and run faster and run with less GPUs. So that's another kind of like big bottleneck, I think, right now to many people. Yeah, so probably those two that comes to my mind. There's probably a ton of other challenges in this space.
Yeah.
But, yeah.
No, that the GPU concern like that, definitely that I mean, that would be huge. So listen, if you're watching this and you're ready to go take into consideration how there is a huge need for this.
Yeah.
This reminds me, wasn't this what like that old show Silicon Valley? Wasn't that what they were trying to do? Was it a compression algorithm or something? Yeah, that was it, right? So in fiction, it wasn't solved.
Compress those models, but there are ways to compress models, so to make them smaller, but usually
they degrade. Yeah.
Those are degrading the results. Yeah. So the big kind of like idea would be to train a model in such a way that it can be smaller, but still as performant. Yeah, and the model is smaller, you can have smaller devices. So I'm not sure, but on that shelf back there I have like 10 different small devices that are like fitting on the palm of my head and are doing all that stuff. So they're like, there are boards powerful enough, like GPUs, that you just plug into the power source and camera into it, and they can be mounted on all sorts of different things. But they can run object detection model. But VLMs, for example, are large enough that in most cases they're too big to fit on something like this. You need to have something much bigger.
There you go. Free startup idea for somebody watching. Get to work.
I mean, I think it's really easy to come up with like 20 different startup ideas in the world of computer vision. Yeah, so
no joke. So, and I guess that's part of what Roboflow as a company does, right? Like how applying all these technologies for their different customers. But I love that they have this incredible mission to make sure that the open source as power in this continues to grow and thrive. The fact that you work there, like I feel really good about it. That's really cool.
I mean, I very often say that's the best job I ever had, for sure. Especially if you have this kind of like joy from doing open source stuff. So we can build those things, and we really kind of like believe in the open source also. So, a testament to that is, I don't know, this repository with like notebooks, like all of that is open source. All of that is, we show you how to do it without us. Like you can just hop on a Google Colab, take the open source model that is completely free, and train your stuff. Yeah. But then what we can do is we can help you out to deploy that model, for example, which is another layer of complexity that depending on the size of the project, can be really hard, and we can make it as easy as just running a few commands in the terminal, and you have your model running.
Amazing. I remember we were talking before when I first reached out to you. You said like notebooks is like probably one of the most understated repositories, and I see why now. This is pure gold if you're interested in applying this to anything you're working on. Like the examples and how well done and comprehensive, being able to just open the notebook right from there. You can open up on Kaggle. You can read the blog. You can link to your YouTube.
Example of notebook that is dedicated.
Yeah, let's take a look.
We'll not run that yet, but I can show you. So those are not like random notebooks that we just created. As like step by step the whole process with like detection and tracking and showing you how to understand what team the players are playing for. So we then show you something like this, where you can where you can, I don't know, click on individual players and they are all from the same team, and we just few cells above, we just show you how to do that. That's another thing that you can think about, like, how many applications for something like this, looking for similar images or similar things you can have. All of those, like reverse image search, where you upload an image and you get similar images. This is the same principle. We just applied it in sports, for example. And we showed you now that we can divide the teams. We can, individual referees, individual players. The fact that those colors are different is coming from the fact that we are able to detect, track, and understand what team they are playing in. Some people can say, oh, but they are in the same jersey colors. Just through looking for examples like here, you can see that those players are in, this is very small, I can imagine that. But you can see that the color, there's different light, there are different poses those players have. So it's not that easy as understanding the average color of the crop where the player is.
Right.
Because the average color can drastically change, where, I don't know, when part of the football field is under sun and part of it is in the shadow. So we do this. We do another thing which is interesting. We spoke about those like model that can detect the pose and individual joints in the finger. So now what you can do is you can apply them to sports. And instead of detecting like individual joints, you can detect like characteristic points on the football field. So it's happening here. So in our demo today, when I was showing this notebook, I needed to provide. Sorry, I'm scrolling a lot, but I need to provide those like points individually. So I told you I measured them. But what you can do actually is you can train another model that will detect those characteristical points and then automate the whole process. And that's the same model that you would use for post detection and for those fingers. You can say, okay, now I would like to detect characteristic points over here and detect those points. So then I can do mapping of those positions of those points, and I can map the position of of players from this image to the kind of like this radar view. And this is exactly what we did today. So the same transformation, the same kind of like you scan the document, you get this kind of document. I'm just detecting those characteristical points, just as the app that scans documents, it detects the corner. So I'm just not interested in the corner. I'm interested in like 32 characteristical points on the football field, because I not always see the corner. Like for example, I don't see the corner in this place, but I can see this part, and that can also help me out to figure it out. So instead of tracking 4 points like those apps to track to scan documents, we track 32 points. And we use them. Then we can go beyond that. We can calculate like advanced stats like this. So we can think about, okay, which point on the football field is closer to which team, for example. We can say position. We can, make it really nice in terms of like visualization. So we can do all sorts of things. We can track the ball, how it moves through the football field. This is the cleaned version. So you can see how through the 30 seconds where the ball was moving, and opportunities are endless. That's another hard problem. Tracking small, fast-moving objects. If you would like to do that, that's another probably a good place. Like ball, for example, in sports, that's something that's very small usually, especially like hockey, for example, when stuff moves really fast and it's very hard to see even on the large screen. So how to track that automatically? That is non-obvious.
Listen, they're not using this yet. I feel like some of these football clubs that like have this incredible budgets, don't they have like people working on this yet?
I cannot find that tweet right now, but I retweeted a job offer, like Liverpool, I believe, was the
Get out.
And they literally had a job offer that was like bunch of visualizations just like those from that notebook, and I was like, we are looking for data scientists. So that's true. NBA is another place where that happens, where you can see from time to time they use advanced analytics to know which player to trade for because it suits their style of play. So there are companies that are doing that for like at the very large scale for those leagues, where they pretty much analyze the whole seasons. So every video from every game from the whole season, and calculate all sorts of probabilities that the player is more likely to score from there. What's the dump on the shoot probability when they have hand in the face, or where there is no defender, or where they are 18 feet from the basket or 25, and how that all influence. They calculate all that, and they provide that insight. But another interesting thing that is also happening right now, and I remember I tweeted that some time ago, and a lot of people get really upset, is when you get this AI augmentation. So you watch the game, but suddenly somewhere over the player is his name, or the player is getting closer to scoring the goal, he or she is closer to goal, and suddenly you see a measure of probability that they will do a pass or shoot. So something like that can right now happen, like in live video feed, so you can watch the game.
That's amazing.
And a lot of like those hardcore fans that just believe that it's all camaraderie and numbers cannot express the influence of the player and all that stuff, they get really upset. But there's also a group of people, those are mostly the younger generation, that is kind of bored to watch game for 90 minutes, and that additional information helps them to kind of like stay focused.
It's a video game now. Like I can see my stats of my player, and listen.
Exactly.
Here's another free startup idea. Some betting.
Oh, that's another one. Every time that I shared a tweet about this project, there is like at least 2 or 3 people that are hitting my DMs on Twitter and say we should have a startup to calculate the betting probabilities. So it is something that already a lot of people have thought about, guys. So I'm not sure if we can cut up to them at this point. But
I mean, it's amazing. Okay, we do have a question I want to get to, and then I gotta let you go, because Peter, I could sit here and talk with you about this all day. Like
I can stay. It's Friday.
This is like one of our longest open source Fridays ever. Usually I'm like 45 minutes, and folks, but people are still here. Like, this is super interesting. All right, question. Are there notebooks or blogs to implement object detection model training from scratch, like explain localization and regularization losses?
Okay. So from scratch, like, so the question is from somebody who is a little bit deeper into the topic. So, the question is like not about like high level models, but something that would go beyond that and kind of like understand how those things work internally. So we, not every time, but sometimes we release, when the new model drops, we release a blog post, that shows you how to use it. But we also release a blog post like what is new in that model, how did that happen, and we kind of like do this way. Another place that I need to confess that I really want to build on that. This is my GitHub profile, guys. You can leave a star, you can follow, by the way.
follow, like and subscribe.
Yeah, exactly. But another thing that I want to build is around VLMs. So this is like VLMs 0 to hero. This is kind of like more of a recent topics. If you would like to understand how different models work really deep, then I plan to explore that. For example, here we have a Google Colab that explores something called word2vec, which is something that happens is all of those models, when they read text, they convert that into mathematical representation, into like matrices. So every word is actually a vector 1 by, I don't know, 712 or whatever values. So this is probably more towards what Uncle Drew, by the way, cool nickname, was asking about, which is how those things work internally. So diving a little bit into the math, I, for example, re-implement the whole model from the paper from scratch without any high-level libraries other than like NumPy, I think. So you can understand how those things work and how those models train. So I'm just training the model from scratch totally. And yeah, I don't know. I have an example where I show you that it actually works because those embeddings are actually working. Because similar to what we done with the players, by the way, then we calculated embeddings for those like crops so that we've been able to group them. This is the green team, this is the red team. So you can also convert words into vectors and group them and say, okay, those are like Greek gods, and those are like countries, and those are cities, and I don't know, animals. Yeah. So yeah, if you look for like research like that, I need a lot of motivation to go back to that project and continue it. So if you would like to leave a star and move me towards that project, is
I love that.
VLM 0 to hero. That's the place where you need to leave a star to get me more motivated.
Listen, Peter, we need it. Okay, we need a study group from you. We need a weekly stream. Just saying, there's so much to learn yet.
I even bought the green screen to work on that. So I just have so much work at Roboflow, all of those libraries. So at the very end, I am just so tired that I don't have time to kind of like build my own stuff anymore. But maybe I will. We'll see.
That's amazing. Thank you for putting those resources already. And that's already a ton of stuff that we can kind of get started off. I'm gonna share your profile link. Could you pass it to me on the?
I can send you the link to my profile on GitHub.
Yeah, please do. And folks, thank you so much for being so engaged and still hanging out here with us. I'm gonna pass you now on screen. You're gonna see Peter's GitHub profile. So give him a follow so you can see whenever he publishes something new, and then also follow him on social. Subscribe to the Roboflow YouTube channel so that you can keep learning about this. I feel like
yesterday we had a stream that we were like 90 minutes packed with like information about latest models. So what we try to do is, so I have 2 streams back to back. One yesterday on our channel and one today with you.
So you deserve your weekend. You deserve to get off. Take the rest of the day off.
I need to stay away from computer over the weekend. That's for sure.
There you go. But this has been fascinating and super educational. I honestly came here with like a very limited understanding of how computer vision worked, and I feel a lot more confident that I can explain like what an annotator is. I did not know that at the beginning of the stream. So this has been amazing. Yeah, this has been amazing. Thank you so much for being here, Peter. I appreciate your time and willingness to teach us and to stay a little bit longer. I go ahead and share all the links. Folks, if you have any other follow-up questions for Peter, like engage him in social. I know you're very active, so I'm sure maybe he'll reply.
For sure. Another place where you can maybe find me is our Discord. So that's a Roboflow Discord.
Let's share that.
But especially if people would have questions, that's probably the easiest way to get me is through that Discord. I'm also on social media, but I need to stay off social media more.
Don't we all, Peter? Yeah. Don't we all?
Some time ago, there was this project where somebody calculated the ratio of commits on GitHub versus tweets on Twitter, and your ratio kind of like said something about your personality. So I need to work on that ratio.
Golly. Okay, listen. I see you. I don't judge you. I'm in the same boat. Okay, so the Discord channel, the link to join the Discord is now on the chat. If this is interesting to you, go geek out at it with the people who are building the technology that you can use. And also, my boss says I'm gonna write a blog post about computer vision. Peter, I'm gonna need a collab here because
Yeah, I mean, I can help you out with the blog post. I will be in Chicago in 30 days. We can collab on
so
this.
cool, so cool. I super appreciate your time today, Peter. Thank you. This has been awesome, and thank you all who stay and hang out and learned a lot. Don't forget to follow on GitHub. And I think the notebooks repo needs a lot more stars than it has.
Yeah,
We need to
let's cross
blow it
2,000
up.
stars
Let's
first.
bring it to trending because it is an absolute gold mine. We had somebody else got up earlier also commented like it's a gold mine. There is so many ideas there, not only for you to get to learning, but also to like legit start your business, like build something meaningful and go sell it.
Yeah,
Thank
for
you,
sure.
Peter. I appreciate your time today. I hope you have an amazing rest of your day and take the rest of the day off. You deserve
It'll
it.
be very easy because where I live it's already 7:30 p.m. So
There you go.
I'm just
And I think
and that's it.
I love when I have a guest that I feel like we should talk more. You have to come back.
I mean, if you will, invite me once again, I'm super happy. I didn't even scratch the surface. So,
Yes, you left us all curious, and so that's awesome. All right, well, thank you so much, Peter. Enjoy the rest of your weekend. We'll see you soon.
thank you very much.
Thank you all for still being here. Like, what? This is one of the longest Open Source Friday streams I've ever done, but this was such an interesting topic. I'm fascinated by it. I want to play with it. I feel like Peter, like there isn't just enough time. But listen, if you watch the stream and you started building something with using computer vision, or you started to contribute to any of these projects, please let me know. Love to learn what you did. And thank you all so much. And thank you, Uncle Drew, for the amazing questions and the interactions. And we'll see you next week for another Open Source Friday. What are we talking about next week? Oh, we're going to talk about fun ways that companies are making all this open source stuff happen, right? So we're gonna be talking to an OSPO, and yeah, there'll be some practical things there for you to take back to your companies if you're interested on maybe, I don't know, open source products, or maybe leading more into open source technologies for your own company's growth or for your own startup growth. I swear, when I see Uncle Drew or Grab's business blowing up on socials, I'm gonna be like, remember, you can buy Open Source Friday. Hey, I'm all good. Just sponsor the projects. Appreciate you all so much. Thank you. Have a great rest of your week, and we'll see you next week.